quite.
Oh, it's just, what's that? People ask me, what do you do? Well, I'm really good at being ethical hacker.
Yeah.
What do you mean?
Well, it bothered a lot of people.
And I said, okay, I'm unsecure. I want to get this.
That's the euphemism for it.
Penetrate for that.
Yep, that's it. Yeah, yeah. Yeah, people do get worried. All right, so let's see. I think there was actually some news we're talking about. I got a schedule up there. Maybe nothing too exciting. No, it'll come up later. All right. Actually, the only kind of fun one was this one. And this is Kaspersky explains how their software works. What they claim is somebody at the NSA took the stuff home, put it on his machine with Kaspersky, and it recognized the source code as malicious and sent it up to their server for further inspection. And that's how they got it. And they say then when Kaspersky realized it was proprietary source code, he told his company to delete it and not keep any copies around, but somehow the Russian government got it. And, you know, it could even be true, but it doesn't really help him much. I mean, it's certain, and it does actually raise the interesting thought. I mean, I remember a time, like Windows 95 came out, you would buy a floppy disk or a CD with Windows 95 on it, you put it on your machine, people didn't use the internet a lot, and the whole point was nothing would ever go on your computer without you putting it there. And the whole idea of automatic updates was highly controversial. Wait a minute, you mean Microsoft puts code on my machine without my consent? And now we've got antivirus that just takes files off your machine and sends it home without even telling you. And we're wondering how we got here. You know, inch by inch, we've just accepted that these antivirus companies have root on your machine and they just take whatever they like and do whatever they want with it, and you never even know. So, and these are like corporate machines with confidential documents and proprietary secrets. And how do I know that they haven't just decided to steal all your PDF files this year? How would you ever know that happened? Anyway, it's an interesting issue. And that's why, you know, I thought it was very strange that the article that went through what you should do about Kaspersky had a whole list of other products to use, not one of them made in America or even Britain. I mean, the one was made in Finland. I don't think we're at war with them, but software made in China. And do you really think we'd be happier with Chinese software on our machines than Russian? I don't know. I think Trump would probably rather us have Chinese than Russian. Anyway, but I guess it's like cars. Our native products aren't much good, so you have to choose which foreign product you're going to trust. But, you know, this whole antivirus thing is very disconcerting, and quite a few security experts have been denigrating antivirus and testing it, saying, you know, the antivirus is a very strange product from a security point of view. It's very ineffective at stopping threats, and it changes your whole security model to where you're trusting a lot of people more than you realize. So anyway, it's probably still a good idea for most machines to have antivirus on them. But it's certainly, if I was a corporate security officer and I wanted to sign confidentiality agreements and promise not to leak data, I would be pretty worried about that. And I would probably use a weaker American product than a foreign product. But even so, you don't even want American antivirus companies stealing your stuff. Anyway.
At least 15, 20 years, and it's barely ever really picked up anything that.
That's right.
I really didn't. A couple things here and there.
Yeah, no. In fact, when Vista came out, one of the Microsoft engineers on Vista said, "I don't even run antivirus," and everybody screamed and yelled. He said, "Well, okay, we officially recommend that people run antivirus, but I haven't either in a long time. It doesn't really seem to be necessary for what I do at my computer." But well, even when I've used PCs, I did. Not after XP. Yeah, what's up? Oh, I didn't know he moved it. Oh, well, last I knew it was down in 37. That was like just a couple of weeks ago. Maybe they're just here for one special occasion or something. Because that's supposed to be the Internet of Things workshop or something. 211, yeah.
Okay, so maybe they lecture down below.
Maybe, yeah.
It's a little odd, but
yeah, yeah. Anyway, good. Oh, yeah. All right. I think it's the blue one. Nope, it's the green one. All right. Sure, sure. Okay. So anyway, let me get on to this chapter because it's good, clean fun. And I got to add some fun stuff from latest Microsoft improvements. Microsoft has been working on security quite vigorously for years and even more lately. So this is OS vulnerabilities. So we're going to talk about Windows and Linux vulnerabilities, how to find them and how to fix them. Mostly Windows, of course. Windows has most of the market share in servers and desktops too, I think. The only thing it doesn't have market share in is mobile devices, where it is pathetic, and that's what Ballmer saw coming 5 years ago and totally freaked out and made disasters like Windows Phone and Windows 8 trying to fix it with no luck so far. Mobile devices are, Microsoft is like 1%, but for a lot of the rest of computing, they're really big. So Windows is the king of vulnerabilities and poor security because they held on to a posture of no security for more years than anybody else and became popular that way and built up an incredible backlog of security problems that it's taking them more than a decade to chew through and fix. Up through Windows 2000, Microsoft's official position was that the product should be made easy to use. So everything should just be turned on by default. So when you install a Windows 2000 server, it's a web server, an FTP server, a telnet server. Everything is just turned on by default, so you don't have to bother. Just put some stuff in the file and it serves it up as a web page, and they didn't care about security, so they didn't mind any of that. And then when they got hacked like mad, they decided to fix it. So from 2003 on, the product is sold to you in a broken state with everything turned off, and you have to figure out how to turn on services to use them, which is certainly harder for the marketing department to push as ease of use, but it's much more secure. It's not an FTP server unless you go in there and find an FTP service and turn it on. And that's the way it ought to be from a viewpoint of security. So the CVE list is, of course, the taxonomy of vulnerabilities, and there's always a ton of vulnerabilities in every version of Windows. There's just a constant flood of updates and patches. Microsoft has the most mature patching system. You can report vulnerabilities to Microsoft and they will very quickly give you an answer whether they're going to do something. They know of hundreds of flaws in the product and they carefully choose which ones to patch each month. There's a ton of the problems they know that they don't patch because they would be difficult to patch and they're not currently being exploited. And they just put them on the list and they wait until they have to patch them. And they have often judged, probably correctly, that for a lot of vulnerabilities, it's better to just conceal them than patch them. As long as nobody else knows, it doesn't matter, and that's the way it goes. I think all the other products that claim to be high and mighty and not have that attitude just don't know about their security flaws. I think that's true of every product. It has hundreds of flaws that people could find that the manufacturer is not fixing, either because they don't know about or because they just don't want to waste the money fixing it. And that's why, you know, sophisticated attackers like the nation state and military can get in anything, anytime. Because if you're really at a high level, you can find vulns and get into almost anything, anytime. The only thing our updates and patches and antivirus do is scare away the lower level attackers, which is most of the threat for a normal user. I mean, if the military is after you, you're dead meat. Doesn't matter anyway, most of us. So we should arrive hoping that we don't have the military targeting us specifically, and it's just people that want to steal our credit card, and those you can maybe stop. Anyway, so the file system is at the heart of the thing. You have to have some way to attach names to files, some way to put files on a disk, some way to clean off the files and all that. So the file system is the basic structure used to organize the disk. And the original file system was the file allocation table system. This was designed for floppy disks and then modified for the early generation of hard disks that was small and went through a few variations, FAT12 for floppies and FAT16 for small hard disks and FAT32 for big hard disks. But all of them were designed before the internet, so they had no security at all. Physical possession of the disk meant you could read and write every file on the disk, and there was no way to say Joe can read but not write, but Sally can read and write. That was what Microsoft regarded as their home product based on the FAT list, where it was a home user owned by one person and they expected full control of every file in the box. This is, in retrospect, pretty silly because even home users probably have children that are going to play with the box, and you don't really want them deleting all the system files. And this is when I think Apples were considered much safer, because Apples would make it so if you click on the icons and drag them around because you're 2 years old, you couldn't really wreck it so it wouldn't boot anymore. But you could easily wreck MS-DOS or Windows by doing that, so it wouldn't boot up anymore. Anyway, that was no access control list. So NTFS came out to be Microsoft's business product. It came out with Windows NT in 1993 and all later versions. Microsoft had many promises to come up with a new and improved file system, but they never did it. They just stuck with NTFS. And so it had minor changes through the decades, but it continues. This, instead of having a file allocation table that has just so many fields of information about each file, it has a database that can grow as big as necessary with records about each file. So you can have a long list of who can do what, and it will just store all that data attached to the file name, so that whenever anybody tries to access the file, it will figure out who they are and compare them to that list and decide whether they should be allowed to access that file or not. All right, in the later versions, you got compression, journaling. Journaling was really important so that it writes down everything it does as it works. So if the machine crashes or the power goes out, when the power comes back, it can pick up where it left off. Before journaling, you had the Windows 98 thing where you'd boot up your machine after a crash and it would say, recovering lost clusters. And it would find all these fragments of files on the disk without knowing what they were and sort them into the root of C and make file 000, file 0001, and so on. Because if it was halfway through a read or write operation, it would just be gone. And when it woke up, it would find these fragments of data and have no idea what they were. Whereas with a journaling file system, unless the journal gets corrupted, it can just find out, oh, I was halfway through a copy. Well, I'll just finish the other half of that copy and everything will be fine. All right. Alternate data streams are a feature Microsoft added to be compatible with Apple. At least that's what I heard. That's the only time I ever heard of that happening. And the point is, Apple focused on media. So they would have a file name, and then you'd get something like a song, and they would have 2 or 3 streams of data tied to the same file name. There's the music that will play, there's the cover art, there's the copyright information. Instead of having different files for those things, they would have one file name with multiple streams of data coming off the file name. And Microsoft has this feature. I'm not going to bother doing it live because it's not that important anymore. But what you can do is you can make a file. So I make a directory, I have a file called foo, then I echo this into foo:\bar. So I make a file called foo, and then I put data in a file called foo:\bar. So I treat the file name as if it was a disk drive letter and put another stream of data called bar in there. Now, if I do a dir, it'll tell me that foo is still 6 bytes long, but it's lying. Foo has a second data stream that dir doesn't show you. You have to do dir/r to see it. Foo now has 2 streams of data, one 6 bytes long here and one 31 bytes long there, the alternate data stream. And the reason this matters is because just like the dir command can't see it, there was a time when antivirus programs couldn't see the alternate data streams, and you could hide stuff in there. It was just one of the many places you hide things to avoid detection. Now, of course, modern antivirus is onto this, but there's always some place to hide stuff, and this is where bad stuff goes, that you're trying to hide from antivirus or hide from forensic researchers trying to find your stolen property or your malware on the box and so on. Remote procedure calls is a big part of Windows. The whole point of Windows for a company is Windows domains, where you buy a domain controller and you now have one point of administration for the entire network. This is so important. It's the main reason I think why Microsoft makes so much money. Every corporation of any size, every company of any size has to have a Windows domain controller. We've got one, everybody has to. If you try to live without one, you will just discover how expensive it is to try to live without a Windows domain controller. This means you have a lot of machines that are sort of under remote control by the domain controller, and they use this remote procedure call process for that. There's a way for one machine to run a process on another machine. That's by design, but of course it leads to vulnerabilities, because if any one of those has a bug, then you can take over machines through it. So there have been many, many worms that spread through RPC calls. Like Configure, the Microsoft Baseline Security Analyzer is Microsoft's security scanner that will check to see if you have done all the things Microsoft recommends, like put on all the patches. And that certainly should be your first step in securing Windows systems, is to make sure you're at least doing everything Microsoft recommends, especially these days when Microsoft is a whole lot smarter than they used to be about this, and their recommendations are actually quite good to protect you. Now, pass the hash is one of the vulnerabilities in Windows that has been famous for years. Microsoft, see, if you are in a corporation and you log in the morning to your domain controller, then you connect to a file server, there are permissions on those files. It doesn't ask you to log in again. Instead, it's able to tell who you are because you've already logged in. Unfortunately, it does that by just taking the hash and sending it over the network. So you can steal a hash off the network and replay it to get on another machine in a Windows domain. It's very strange that they've designed it that way. I thought that was the whole point of Kerberos, to avoid this, but in fact, you can replay hashes, and one of the best tools for that is Mimikatz, which you used in one of the projects, Project 2 or Project 4. And so for decades, Microsoft systems have been vulnerable to this, and now they're trying to deal with it in Microsoft's way, which is rather than redesigning the system to stop sending something that can be replayed, which would be my idea of how to solve it, they've instead decided to just hide the secrets more carefully. So this was their solution in Windows 8.1 and Server 2012 R2, and presumably later versions, was to add this thing called silos. So you define these accounts. So a high-privileged account, like a domain administrator account, cannot be used to log into a low-privileged device like a workstation where someone's browsing the web and might get infected. You have to have another account without high privileges that logs in there. And that's the point. You make these authentication policies and silos. It's not a default setup, but you can set it up so that the high-privileged accounts cannot be used on low-privileged workstations. And that means they don't leave hashes around on the workstations that are at risk to be stolen. So that decreases the harm of pass-the-hash attacks. It's essentially a form of defense in depth and local segmentation. So that when a user, with a typical way you take over an enterprise, you send email, somebody clicks on a link, somebody gets one workstation infected, then you take over that workstation and pivot from that to take over other machines. And that pivoting step will be more difficult if you're unable to find really high-quality credentials stored on that workstation. Now, this is the new stuff that Microsoft announced yesterday, or the day before. The Microsoft's latest Windows 10 update, which I haven't tried yet, adds 4 new things, which sound pretty good. Attack surface reduction sounds like science fiction. Supposedly it's using artificial intelligence to detect zero-day attacks on the client. I'm skeptical, but people tell me Siri that you talk to on your iPhone is actually AI on the client. I don't know. Anyway, it's certainly there will come a time when we have AI defenses, and this is the first version of it. Then network protection. This blocks outbound connections to known malicious servers. Microsoft has for years had a list of known malicious servers which they use for Internet Explorer and now Edge. So that's why people freaked out when Windows 10 came out and said it was spying on them. If you type a URL in Edge and go there, it sends that URL to Microsoft, and you can see it in Wireshark. And they say, Microsoft is spying on me. And they say, no, we're protecting you. We have a cloud surface that checks to see if that is a known malicious URL. And rather than being like antivirus and sending updates to your machine and keeping the list locally, we keep the list in the cloud, so you send the URLs to the cloud. Anyway, that's how it works. And now they've extended that, so even if you try to, some other program, not Microsoft Edge, tries to make an outgoing connection to a known malicious server, it will be blocked. So this is actually pretty brilliant. And this means they can block connections to command and control servers from malware. At least it sounds like that. One thing I've learned over the years is when Microsoft advertising department, marketing department announces these mitigations, they always sound great. And when you actually see what they do, they really only did half of this. And there's a bunch of holes left in it, but still, it's a step up. And the one I really like was controlled folder access. This one is cool. The scariest threat for most people right now is ransomware. If you get this, it infects your machine, it infects your Dropbox, it infects your corporate shared files. It can really ruin your whole day. And companies are actually paying. So this is actually pretty brilliant. Just put a firewall on a folder. So you turn on this feature in the latest version of Windows 10, you pick a folder like I have my documents folder, and you say, I'm going to say protected folder, and you specify what applications are allowed to use this folder. Like this is my documents folder. The only thing in there is Microsoft Word documents. The only application that should be using it is Microsoft Word. That's what this does. And then if some other program tries to use those documents, it'll just get an error message like this. Let me blow it up, saying access is denied. This is when Paint tries to access something that is not approved for Paint. This is actually pretty simple and brilliant. It seems like it would totally work. Now when your malware tries to encrypt the files, it'll say tough. Only Microsoft Word, you may touch these files. Now, of course, knowing Microsoft, it's probably not super brilliant. You probably could make malware that impersonates Microsoft Word, but still, that's all you ever get. The bad guys, their current generation of stuff will not work, and they're going to have to up their game. And maybe they made it very difficult to spoof. I don't know. That's why I haven't really seen it go to find out its limitations. But offhand, this sounds like a really brilliant idea to me. Anyway, so NetBIOS is, there's the BIOS in your system, the basic input-output system, which during boot up checks to see if you have a hard drive and some RAM and a network connection and such, and boots up the operating system. And then there's NetBIOS that looks around the network for things. And NetBIOS is the protocol it uses to do this. Originally, it was before TCP/IP, a protocol used by IBM machines and then by Windows machines locally. But then they used NBT is what we're really using these days, NetBIOS over TCP/IP, because everything really has IP addresses. And even though you can refer to machines by NetBIOS names, they're actually resolved to IP addresses and referred to by IP addresses. There was a time when you did not have IP addresses on your local area network because you didn't need them. You used these more primitive protocols that are non-routable. So the modern versions still share files using NetBIOS names. I don't know why they continue to carry it forward, even though nowadays we have DNS names. So your machines actually have two names for every box, a NetBIOS name and a DNS name, and two sets, and actually 7 ways to resolve a name. It's kind of nuts, and it can lead to entertaining problems. But anyway, it's still around for backward compatibility. Originally, this all worked over server message block. Just a minute. So server message block ran on top of NetBIOS, and it used authentication techniques that sent these LM hashes over the network. And that was the first generation of loft crack tools. They would steal those hashes off the network, crack them because they were very weak and easy to crack, and they could just steal passwords off the wire and just pass the hash to get into places. So they were able to really break into Windows networks for a long time. So Microsoft improved it. One of the other problems with SMB is it was extremely inefficient. I remember noticing myself, you'd get 100 megabit per second Ethernet network, you'd drag a file from one machine to another into a shared folder, and it would only move at like 5% of the line speed. It was really, really wasteful. So SMB version 2 improved the speed and added a lot more features. And in Vista, they introduced it, and it didn't work hardly at all. In fact, all that happened is it would think about it for 3 minutes and then fast transfer quickly. So it would end up taking the same amount of time as the old slow method. But by Windows 7, they actually got SMB version 2 actually working and accomplishing things. One thing funny about the Windows Vista version of SMB version 2, here I have Windows 7, but I thought it was Vista, they had amazing blue screen of death vulnerabilities. And this is Laurent Gaffié's Fuzzer. Laurent Gaffié is a security researcher that really hates Microsoft, and he found with 10 seconds of fuzzing, he found a blue screen of death single packet killer for Windows 7 or Windows Vista, one of the early versions, because SMB version 2 was really vulnerable. He would send it one packet, and poof, the machine was dead. So Microsoft apologized and explained how they possibly missed that, and he said, Microsoft is lying about their software development lifecycle because next week he just found another one and killed the new version, same way. And that was so Microsoft, after that, started using fuzzing. Fuzzing is a technique Microsoft refused to use because it's random. It's not deterministic. They use code auditing tools and code reviews where you run some kind of scan, it tests for certain problems, and you know what it's done. Fuzzing is where you just take a packet and mutate it. Flip a bit and send it. Flip all the bits. Try flipping 2 bits. Try flipping 3 bits. Try making all the fields longer. Try making them shorter. Just mutate it in all different ways and just keep sending random broken junk to the server and see if it dies. And there's never any end to this. So you just fuzz for some period of time and you say, well, if it withstands 24 hours of fuzzing, I guess that means normal users can use it for a month without hitting a bad thing. So Microsoft doesn't like sloppy procedures like that, but this is what convinced them to do it. He was finding vulns with his fuzzer when all their logical, predictable techniques were not finding them. So now they fuzz their stuff. All right. So they made this thing called CIFS, which was supposed to be an improvement of SMB, and they tried to say you should use it over the internet and everything else, but it was not safe enough for that, and nobody much ever did. But it had a bunch of features to share things and have fault tolerance, so you could, in principle, be sharing them with more users at a time and all that jazz. But it never became much of a hit. Anyway, there's this global catalog server, which locates resources on the network, and then Active Directory, which was a product based on Novell's directory services, which lets you identify every network object at the domain controller. So if you try to print, you don't connect directly to the printer, you go to the domain controller, and it tells you where the printer is. And the reason why this is super important is if you buy a new printer, you don't have to tell every workstation where it is. You just tell the domain controller, and everybody, it pops up in their list. There's a new printer. And if you want to let only certain people use the printer, you just configure that on the domain controller. It's much easier than the old system where you connect them directly to workstations. So your domain controllers control everything that happens on a Windows network, and they have to have a ton of ports open. So when you do an Nmap scan, you can really spot domain controllers. They got all this jazz open. They got to have Kerberos and 88 for logins, and they got to have RPC, and they got to have LDAP for logins. And all these things are typically on your domain controller just so it can do its job. So it's not subtle at all. We talked about null sessions. Versions of Windows before 2003 or so had a lot of information available to anyone who logged in with an empty name and an empty password. And eventually, that was, even Microsoft couldn't explain why that was happening, and they turned that off. So NetBIOS still is used to refer to machines and network shares and servers, and you can use any of these tools that we talked about in previous classes to enumerate the NetBIOS shares. It's not necessarily a vulnerability, but in fact, there frequently are vulnerabilities in the file sharing system. So you should typically block port 45 at your gateway and not let anybody connect on the internet to port 445 because it's just been historically too vulnerable. There's just an endless series of weaknesses. Now, IIS, in early versions, Microsoft's web server was fantastically vulnerable. It had directory traversal vulnerabilities. You could just go // Windows System32 cmd.exe in the URL and have a command prompt on the machine and issue commands. It was just amazing. But Microsoft improved it in every version, and there was a wizard written to try to take your IIS-4 websites and migrate them to IIS-5. My friends that used it told me it was terrible and broke everything, and you really had to just redesign your whole website. But Microsoft did get a lot more secure in each version. All right, and SQL Server was another laughingstock of the internet. The open source people used MySQL to store data. Microsoft's alternative was to make SQL Server, but until 2005, when you installed it, it would just, if you just click next, 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 you would have an account with no password at all that was the administrator account called SA. So tons of real databases on the internet were running that way. And by the way, the same thing happened with Mongo up to last year and the year before. Mongo is the new hotness in databases. People love it. But the Mongo manual tells you this thing is not safe, don't install it on anything connected to the internet. And there are thousands of them connected to the internet with no password, no protection, and there's just tons of data getting stolen from them. This keeps happening over and over again. But at this time, they didn't even warn you. So anyway, that was kind of one of the many bad, that was the old bad Microsoft. A buffer overflow is another vulnerability that keep coming around and around, where the programmer designs a program with a certain amount of space, like we did last time with the password with so many characters, and if you put in more characters, instead of just throwing them away, it accidentally puts them in a box that's too small for them and gives you the possibility to take over the machine. This is almost entirely because of C and C++. All the other languages I know of prevent this automatically in language. C and C++ are too close to machine language. They never question their orders. They just do any stupid thing you tell them to do, including overflow the buffer. Passwords are typically the weakest spot in a network. I don't know if I'd argue about this. Anyway, social engineering is certainly the weak spot, and passwords is one common one. I just read another news article today said that there's a company selling Windows remote desktop protocol servers. They've taken over thousands of them by just guessing passwords. And so if you use obvious passwords, people can get in and then they're in control of your box. This is a common problem. So there's a bunch of recommendations about passwords: change them, make them longer, make them complicated, don't write them down. This all drives us all nuts. I think in practice, what people should really do is use a password manager or write them down on a piece of paper, but whatever you do, don't use the same password at multiple sites. That is probably one of the worst things you can do. Yeah.
Would it be beneficial to do like two-step authentication instead of just using just strict passwords?
Oh, yes, of course. It would be much better to use two-factor authentication whenever you can. And that's certainly good for how much as you can stand to. But many services people use don't allow two-factor, and many people aren't willing to put up with the annoyance of two-factor for everything. But yes, two-factor authentication is much better than any kind of password. All right, so configure your domain controllers. You can put on these restrictions that will limit this. If you put on a password age, that forces people to change their password after it's a certain age. You can force them to make them a certain length, and you can turn on password complexity, which was Microsoft's attempt to get passwords that were not in dictionaries by forcing you to use uppercase, lowercase, symbols, and numbers. You had to use at least 3 of those things. This is obsolete information. The original point of that was to stop people from using dictionaries like English dictionaries to guess passwords, but for at least 5 or 10 years, we've all had access to stolen password dictionaries like the RockU database. So nobody that has any clue what's going on tries to crack passwords from English dictionaries. You crack passwords from dictionaries of stolen passwords, and they do have numbers and symbols in them. Anyway, Account lockout threshold is quite useful to stop online brute force attacks. This means somebody can only have 3 bad failed logins in an hour before you lock them out or something like that. That will stop people from trying hundreds or thousands of logins over the network. And your lockout duration determines how long they're out. LM hashes should be disabled, but I don't think it's a big issue anymore because there's no longer any supported version of Windows that uses LM hashes unless you actually go and turn them on. It's all off by default ever since Vista, which is good. And so, good, we're down to the Cahoots. Just about the right time. Good, I've got plenty of time to do the Cahoots. So, I'll bring them up. Log in, turn on the glorious Kahoot music. My Cahoots. There we are. Oops, not that one. Yeah, I don't know. I bet you could probably just record it. It's probably just in your temp files or something, you know. You used to see all kinds of music that way. A bunch of music players had that property. Okay, so there we are, 480-781. This is October 25. All right. Enjoy. They missed Chan. I don't know what happened to Chan, but anyway. There are lots of in-jokes I fail to get. I know. When I was in grad school, I used to laugh at my professor. He never did anything like somebody building a lightsaber and he had no idea what it was. He never saw Star Wars, never saw anything. You know. Now I'm that guy. All these things are jokes about things I have no clue about. Anyway. I'll wait another 10 seconds. Whoa, they're going down instead of up. Okay, I better go before everyone else quits. So, all right, 5 questions. All right, what's the file system on a floppy disk? These ancient things that you don't see anymore. Okay, fat, that was it. All right. What feature puts 2 files under a single name? All right, alternate data streams, good, a popular answer. All right, what protects you from ransomware? All right, controlled folder access, sounds great. We got to try it out and see how great it really is. Anyway, what product had the lockdown wizard? It was IIS, Microsoft's web server. All right, and what port does Kerberos use? All right, it's 88. I was thinking this was easy because these others you should spot even if you don't know that one. But anyway, it's 88. So here are the winners, Cam and Kaji and Tip Tip. All right, I'm going to restart the share. I think we can just go on with the next bit here. So you remote viewers, just come back. We're going to end this.